Welcome to physics class, and today's class we are going to be looking at atomic model. But before then, when I was growing up, we learned that an atom is the smallest indivisible particle of matter, but this actually true. To understand what an atom really is, we shall be considering the topic atomic model. Now, atomic model, the most interesting aspect of physics. When we talk about physics, and a lot of people consider physics as a very intriguing topic, but to me, physics is life. Every other topic or every other subject, they all emanate from physics, because this is a kind of course that studies the physical world. Therefore, this atomic physics we are going to learn today is going to meet you at a very interesting aspect of it. So sit back, relax, while I take it through. By the end of this lesson, the students should be able to explain the concept of matter, the concept of atom, discuss the various models of atom like the Dalton, Thomson, Rutherford, Bohr's Electron-cloud model, and then highlight the limitations of these models. Now, the concept of an atom are the basic unit of matter and the defining structure of elements. We now know that atoms are made up of three particles: proton, neutron, and electron. When we talk about this atom, like my study into quantum mechanics has really made me to understand better that when we talk about atom, we are really talking about something beyond the scope of the human understanding. Most of these models we are going to be studying today are a kind of assumption, apart from Rutherford, who did a kind of alpha scattering experiment, which shows us a little of the behavior of atom. But you see, the study of atomic model has gone far beyond the normal understanding of what we see, and the basic common sense of human beings may not be able to go truly into the underlying factors of what atom is. Now, the concept of atom, according to what the scientists have come up with, and according to the classical aspect of physics, when I'm talking about the classical aspect of physics, I'm talking about what Sir Isaac Newton said about physics. And when you look at an object, for example, a ball, a body, rolling down, whenever something happens, you can predict the end. For example, when you throw a ball, you can predict when it will fall down. You can predict how long it can stay on the air. This is what is called classical physics. Why? Because you are seeing it with your eyes, but can you see what is happening inside your blood? Can you see what is happening inside the water? Now, this atom is something that your human eyes cannot see. But what the scientists came up with, after several scientists of old have given an insight of what they feel about what does not exist by the physical eyes, they came up with what you are seeing on the screen. They say that the atom, that very smallest tiny thing that you can only imagine, has what is called the nucleus, which I am showing you on the screen. This round part of it is nucleon, and inside the nucleus we have the proton and the neutron, right? Why that the electron revolves around it, and this is what this is what you and I are taught in our basic science studies that atom is. Now, somebody should be asking, what is this atom, by the way, and how does it help us? But I want you to know that the reason why you're watching and seeing me from wherever you are is because of an atom, because of the study of atom. And that is why I say that physics is something so big beyond what you are knowing. Physics has gone into biology, even like the man Edwin Schrödinger, when he has his study of atom, he later go into biology. And that is why we have physics, we have biological physics, we have chemistry physics, and all the rest of them. And for now, this is just what atom is all about, what you know. Now, let's go into the models of atom. What do I mean by models? Can you imagine anything? Whatever you can imagine which is not in existence is called model, all right? You just model it in your sense. And that is what has born invention. Whatever you model, if you can bring them into a physical picture of being, and then you start building it, then an existence of something has begun. the models of atom first. Before I go into what John Dalton said about atom, I want to remind you of the man called Aristotle. You know, if I remember this man, it's something that fascinates me because this man almost went into all fields. Like when he came to physics, he started talking about physics. And most of the things he said was proven wrong. But then he was seen as an authority because of his knowledge and he was well read. He came up with atom. Before then, Democritus was the man that talked about atom first. He said that atom is the smallest indivisible part of any body, smallest of it. And Aristotle came and said that it is not true. And because they believe Aristotle to be an authority in the field of academy, as an academia, everybody believed him. And the idea of what Democritus said died for over 2,000 years. Then came the man John Dalton. Let's look at what he postulated. Like, remember what I mean? He just postulated it. It's not that there was an experiment conducted about how atom looks. But John Dalton said that all matter is made up of tiny, indivisible, and indestructible particle called atom. All matter. What is matter? The air you breathe, the object you are seeing. That inside the board you are looking at, inside the book you are seeing, that there are tiny, indestructible particle, the smallest of it, called atom. The next thing he said is, all atoms of a given element are identical in mass and property, but differ from atom of another element. That means the atom of this marker is different from the atom of your phone because they are coming from different elements. Matter can neither be created nor destroyed. That was what he said. Then atom of the same or different element can combine to form compound, like we have hydrogen molecule. He is just saying that if you have atom of hydrogen and atom of another hydrogen, you can form probably hydrogen molecule. That was what John Dalton said, and people believed him, and it became something to work with. And remember the year he said this, 1766, and he ended at 1844. Now let's go straight to talk about some of the limitations of his model. All right, Dalton atomic model. Look at it. This is a sphere. Also, Dalton talked about a sphere. He said oxygen atom at 16 mass units each. Then plus 2 hydrogen atoms. I have said that already. 1 mass unit each, and this forms a molecule of water. When you have 1 oxygen and then hydrogen atom, then you form hydrogen of water. Remember that, which is oxygen plus hydrogen of water forms H2O. So this is compound. This is water, this is hydrogen, and this is oxygen, and this is hydrogen atom or hydrogen molecule. So that was what John Dalton said and proposed about atom. And I think he's correct because we are still using this idea today. Then what are the problems and the limitations? I mean, what Dalton could not see at that time, and also based on the fact that what he said, he was just proposing, he was just imagining it. He didn't carry out any experiment to say this, and because of that, there are some limitations, and we are going to look at them. Number 1, contrary to Dalton's model, atom can actually be subdivided into series of atomic particles like proton and neutron. Then, Dalton claimed that all atoms are the same in all respects. Hence, his model falters in explaining isotope. We have what is isotope. For example, you can have a particular element that has an atomic mass but different atomic number. So as a result of that, Dalton was a little wrong in explaining what that is. Then also what Dalton could not see, Dalton's theory does not explain allotropy, the property of some chemical elements to exist in 2 or more different forms in the same chemical state. Example, carbon exists as graphite and also as carbon. So these are a few things Dalton could not be able to see when he was making a postulation about what an atom is. Of course, nobody is perfect, even the genius of them. Even somebody who was as good as Dalton, as he's dead, he was not perfect. So there is no perfectionist in sciences. Let's keep going. This young man, Thomson's atomic model, proposed by Sir J.J. Thomson. As an Englishman, you need to put Sir as a title for him. An English physicist around 1900, his work is also known as the plum pudding model. Let's look at it. I think I'll first show you this before you understand. Look at this. This is watermelon. And if you look at this watermelon, you see the whole body of watermelon is filled like a cloud. But what do you see? You now see some nuts, kind of seed of the watermelon. Now that seed, he's looking at them as the electron. Each seed represents the electron, while the whole body of the watermelon is seen as the positive charge. So what Thomson's atomic model is saying is that the whole body of any sphere is positive, that every part of the body is positive in nature or is filled with positive charge. Why? There are a kind of small distribution of some electric charge in the name of electron. Electron is scattered around, but the whole body is positive. That was what he said. Now we are going to find out if what he said is true. Then that was the first thing. We continue. He said that the atom is a homogeneous sphere. Look at it. A whole body of a sphere of positive charge. That means anybody you see, for example, if you hold your phone, that the whole body of your phone is positive. Then inside of that particular phone are embedded, small slots of negative electrons, scattered around. Let me give you, for example, if you draw a circle, look at this. If I draw this circle, and this circle is all about positive body, the whole body of the space or the area of the body or region is positive charge. Then I start slotting in negative charge. You slot this is negative electron, scattered around it, just like what do you call that? Just like your watermelon, where the whole reddish part is positive with some seed, scattered as electron. That was what Sir J.J. Thomson stated about atom. So we are going to find out if what he said is true or not. Then after that, he said that the mass of the atom is uniformly distributed over the atom. The mass is uniformly distributed. That means there is no particular place where the mass of an atom is concentrated. Then they also continue to say that the model explained that the atom is not indivisible or indestructible, but can disintegrate. I think he has a point, because now we talk about a kind of disintegration which is in terms of radioactivity. Now the model explained that atom contains enough positively charged components. The model explained that atom contains enough positively charged component to balance the negatively charged component, therefore making it electrically neutral. That means the number of electron and the number of proton must be in equal number, and that makes atom to be electrically neutral. That means there is no net charge. There is no one that is bigger than the other. That was what Thomson's atomic model stated. Now let's move forward. Now, like I explained all this, this is the electron, while this is the whole body of positive charge. Now I have shown you this before, the same thing. Now let's look at the limitation. The major limitation of Thomson's model is its failure to explain the result of alpha particle. What is alpha particle? We are going to look at that. And the guy that talked about alpha particle was actually his student. I think his student, Niels Bohr. No, not Niels Bohr. It's the other man, Rutherford. Now let's go to Rutherford, proposed by Ernest Rutherford in 1911. So it was 11 years after J.J. Thomson proposed his own atomic model. 11 years after, this young man, his student, came up with this. His work is also known as planetary model. Let's look at what he said about atom. He said atom consists of positively charged heavy core. You see, this was after his experiment on what we call the alpha scattering experiment. Now the question is, what is the alpha scattering experiment? Let me just show you a little. So you can also look through your books, and also he got a body. Inside this body has an alpha particle. What I mean by alpha particle is that the body can give out a particle called alpha. Then he brought a plate. Let me use this to represent a plate. A plate has a hole such that the alpha can pass through this. Then he now put a gold foil, and then this place was the screen. So when this alpha passed through this place and was going through the gold foil, this is gold foil. So as this alpha particle was going, remember alpha particle is positively charged, is a positively charged particle. And when it was passing through this, as a beam or a radiation, they are all hitting, some hitting this way, some passing through, some of them are passing through. And some of them, when they come close to this center, to the middle of the gold foil, a kind of plate, they will diverge, some they will diverge. And some of them, when they hit this place, they returned immediately. There was a deflection. Immediately, some of them passing through the center, they hit this particular place, they will return. When he found out that there are a kind of scattering, some hitting a core and returning immediately, he found out that something must have been at the middle for it to be returning. Then because of that, he said, just like what J.J. Thomson said, he said that everybody is filled with positive, everybody of this point is positive, with a kind of something scattered, which is negative. Now, Rutherford said no after his experiment, because experiment is very important. It gives you a wider view of what you are studying. Now, if this whole body is positive, there was no way an alpha particle could just penetrate through the gold foil and just passing through, because positive, there will be a repulsion. So Rutherford said, no, it can never be. This whole place is empty, kind of empty. There was nothing at this place. But at the center comes a positively charged, a positive sphere, which he now called nucleus. And that is what he said. The atom consists of a positively charged heavy core called the nucleus, where most of its mass is concentrated. Unlike J.J. Thomson that said that the mass is evenly distributed. But this man, Rutherford, is saying that at the center is where the mass is concentrated. Where we have center of gravity now, or center of mass, which is still in existence till today. Then he said that the negatively charged electrons revolve around the nucleus like the planet around the sun. The electrons are sufficient enough to balance the positive charge nucleus, hence making it electrically neutral. So the student of J.J. Thomson, I guess so, he said that yes, he believed that they are electrically neutral, but he did not believe that electrons revolve. He did not believe that the whole body of an atom is positive. So this was what he postulated, and because of his experiment, this became one of the best findings about atom, because I think for me, being the only person who conducted the experiment on what an atom is, his studies blew the world open into what we have today. And henceforth, immediately after him, okay, look at what he was saying. This is the core of a positive charge, which is called the nucleus today. And this electron is revolving like the planet revolves around the Earth, or like the Earth is revolving around the sun, going round in circular path, where all the places there are all empty. This is what Rutherford said. And then that was a very interesting one. Now, after that, let's talk about the limitation. The model of Rutherford predict that light of a continuous range of frequency will be emitted. However, experiments show that line spectra instead of continuous spectra was what was emitted, line spectra. The model predict that atoms are unstable. that the electrons would spiral into a nucleus due to attractive force positively charged around. However, we now know that atoms are stable, and since matter around us are generally stable. Let me give you a little explanation to this limitation. You see, like Rutherford said that he said that this is the core, positive core, while the negative electron is revolving around this. There was something he did not explain. Then he said that this was just revolving, electrons was just revolving around the nucleus, but there is something he did not explain. Remember, according to electromagnetic theory of a revolving charge, they say that when a charge is revolving, let me put it this way so that it will be easier for us to understand. This is positive and this is electron revolving. Now, he did not explain the stability of an atom. That means if this is revolving, going this way around this atom, it will be accelerating. And because there is acceleration, it will be losing energy, and because it's losing energy, what will happen? What we see is this will revolve here, we keep on revolving and be coming inside. And when it hits this place, they will blow and explode. So he did not explain anything about that. So like I said, very important point, as this is revolving, they will be losing energy, and inside of that, they will not hit the nucleus and there will be an explosion, or it will go into extinction. So Rutherford did not explain what that is, so that was his limitation. He also did not talk about the, whenever there is a revolving of an electron around the nucleus of an atom, there is an energy emitted, and in such, there is what we will call line spectra, or range of colors, because each color has a kind of frequency emitted. So these were his limitations. Then comes this young man, Bohr atomic model. Bohr proposed Niels Bohr in 1913, 3 years after the failure of Rutherford. I think there was a little correction there. Bohr was a student of Rutherford. So he worked with him. That was where he was able to come immediately after a few years to do this. He said the electron revolves around the nucleus in certain specific and stable nuclear orbit. This is the most organized atomic model, which many people have been using today, before Schrödinger came and Heisenberg came with what they call Electron-cloud, which has given birth to what is called quantum mechanics. But look at what Niels Bohr stated. This is a positive nucleus where there is proton and neutron, and that electron is revolving. But the problem about this, we are not talking about limitations anyways. So let's finish with what he said. As this is revolving, okay, let me assume we have another one. I want to explain this so that you understand. Such that each of these electrons in different orbits are fixed. That means the energy at this point can never be the same thing as the energy at the second orbital. And that we cannot have, he's trying to correct the other man, which is Rutherford. He said we do not have intermediate energy level of this electron, that the energy at this level 1 is fixed, and that you can never have energy from between this place, that electron can never be between one energy level and another energy level. So in that case, he was able to avoid that spiral coming in to hit the electron, which Rutherford could not explain. So he said each of them has a fixed energy level, and that there could be a transition, that electron can jump from one energy level to another energy level, and when it happens, they are going to give off a kind of radiation which has given birth to what we have today as electromagnetic radiation, or electromagnetic spectrum. So that was what the man said, and each energy is different, and there could be a transition from one going up and from up coming down. When this is excited, they can jump up, and when they are jumping up, they give up electrons, they give up radiation, a kind of frequency. And when it is coming down, and when you hit it, when they absorb energy, they can return. So we have what is called emission and absorption. So that was what Bohr atomic model stated. And that because of that, see another place he also said, and they are all revolving this way in an orbiter. And then, you know, remember when something is revolving with a constant speed, they have acceleration, but then there is a force pulling inside, and there is a force that will balance it such that it will not be able to enter through this place. That was what this guy said. And now look at it. He said specific and stable nuclear orbit, also called energy levels, and that the centrifugal force due to the motion counterbalances the electrostatic attraction between these. So he came up with what is called centrifugal, and as far as I'm concerned, centrifugal in physics has remained illusion till today, that there is a force pulling it out which will balance the force of the attraction between the electron and the nucleus, which will prevent it from falling into this place. This was more or less the best proposed atomic model as at the time. And this is what I was explaining, and each of them. But let's talk about the limitation of this man. Look at what I was explaining. So when they transition from one energy level to another, they give off energy, okay? Look at that one. And each energy given up is given as HF, which is Planck's constant. You know, he drew also what Planck stated by his own atomic model. Now, the energy of the electron can only have discrete value. I have stated this. They can only have discrete value. Thus, the energy of electron is said to be quantized. Oh, that statement is said to be quantized. That means it's said to be fixed. You cannot have intermediate. Then, energy in form of light is emitted only when electrons jump from one energy level to another, or to another lower level. So, in that case, we also have what is called change in E, which means when it goes from E2 minus E1, that means the energy level of the second one back to this place. And in that case, this change in E is given as HF, which is the equation according to Bohr's atomic model. And this is what you have been studying even till today in our secondary schools, in our grade 11, grade 10, and grade 12. A lot of us are studying it. But when you go deeper into the atomic model, then you now go into quantum mechanics, which is a little different from what Bohr's model has said. And this has given birth to the phones you are seeing, to the G5 network, to the all manner of technological invention and evolution we are seeing today, is what quantum mechanics has given birth to, which is something a little different from Bohr's model, and we are still waiting for somebody who will come with something different. And also he said also that angular momentum of electron was discrete. That simply means when something is revolving, it should have angular momentum, and this n represents the number of the shell, maybe 1, 2, and 3, and this h is the Planck's constant, because he really included it in his explanation. Limitation. Now, considering the limitation of Bohr's atomic model, now it provides no insight into what happens during transition from one orbiter to another. For example, he only explained using hydrogen atom. And if you know what is hydrogen atom is just one shell. So the Bohr's model was trying to feel like a genius at the point, and everybody believed him. But the question is, after his explanation on what happens for a hydrogen atom, what happens when you now have other shells? When you transition from one energy level to the other, what happened? He did not explain that. Number two, the model only explained the spectra of hydrogen atom, which I have explained, but cannot be extended to atoms with more than one electron. Bohr's model predicts that electrons should produce a magnetic moment, but this is isn't so. All right. Now, what I am going to say in effect is this, because we've come to the end of the classical knowledge of physics, where we cited all these atomic models, but there is a new one running. And this is our generation, where Edwin Schrödinger and Werner Heisenberg came up with what is called electron-cloud model to give the current view of atom, and which has given birth to the new kind of physics, which is the mother of all science, which is called quantum mechanics. Now, let's look a little into that. What is electron cloud? He said we cannot know the exact location of any electron. You see, this is where it gets very difficult, I must confess, because most of the things we are saying in this aspect of physics is a kind of illusion. People imagine beyond what your normal eyes can see, and these scientists, honestly, what they're saying is not what a normal person will understand. Like, they are saying that this atom, this electron that is revolving, that we cannot predict the exact position these electrons are. We cannot know the exact location of an electron at any given time. But the electrons have high probabilities of being in some places. When probability comes into life, you remember it becomes very difficult for you to know the certainty, the truth about an event. So probability has come in now. So it becomes difficult. If probability is something that is true and good, then many people must have become millionaires now in betting companies, in football, and all the rest of them. So they are saying that, look, we don't know these electrons that are spiraling. Let's assume we have this. This is the core. I think they still believe that, the quantum mechanics guys, Schrödinger, still believe that there is a nucleus at the center of an atom. But then that the particular place where these electrons are, we don't know. And that gave birth to slit experiment, to Young's slit experiment, where they said that, you know, I don't want to go much into that, but if you look at that, they had some spaces and electrons are being shot. So some of them, and then if this is a screen, some got at this point, some here, then some here, some hit here. But then if there is a particular place where there are many, so we now have something that looks like this and this one. Why? It's saying that at this higher place, that the probability of electrons occurring here is much more than them occurring at this place. That does not mean electron is not found here. That does not mean electron is not found here. That does not mean electron is not found here. But that the probability, that means the surety for them coming here is too low compared to them being here. That means electron is spread all over the places. But there are places where they are much more in. That is what this electron-cloud model is talking about. The electrons don't orbit around the nucleus, but they move rapidly in wave form. So they left the normal physical happening of an event where you and I, in our normal eyes, can only see that a body is moving around a circle. A car is moving around a bank curve. A man is moving around a circle. A boy is going around a circle. You can use your hand to make a circle. That is what your normal eyes can see. But they said no. That this electron, they are not moving in this format. Rather, they are moving like a waveform on the orbit. This is how they are moving. I think this idea of electron moving in a waveform, I think de Broglie is the man that started this when he disproved Albert Einstein, because the prevalent knowledge at the time was that that light can behave as a particle and as a wave. Then de Broglie, he did not do any experiment. He came up with, say, if light can behave as a particle and as a wave. That means a wave, that means an electron can also behave as a particle and also as a wave. That is which is also in accordance with this, that electrons don't orbit around the nucleus, but they move rapidly in a wave form with a specific energy level. And look at what I'm saying now. Look at it. If you look at this point, you realize that this is electron cloud. So in all these places, this is the nucleus. Electron cloud means that electron is scattered all over the place. But what happened? That electron has higher probability of occurring at this level in a wave format, not like a normal classical normal object you know. Rather, they can stay more place closest to the nucleus than they are spreading out. That is why this bluish gray, this bluish dot you are seeing here is much more closest to the nucleon than they are outside. That means, look at what that means. In any place you see electron spread, everywhere you go there is electron, but there are places where these electrons are much more. That is what they mean by probabilistic approach to the study of atomic model by Schrödinger and Heisenberg. And that is why when you are studying physics at this point, you need to go and learn probability distribution of mathematics, because you need it. Because most of these physics people, like Schrödinger and all the rest of them, they had issue with mathematics, just like you and I. Mathematics is what many of these physicists faced as a problem. So look at this again, electron cloud and all the rest of them. And this is where we come to the end of this class. But remember, we need to use our Examguide app to look deeper into what most of the exam bodies are saying about this topic. So let's go to our Examguide app. In our Examguide app, we are going to, okay, I'm using random for physics, and let me look at some of these major topics. We are going to choose a topic based on what we've learned. I am using atomic and nuclear physics, theories and structure of atom. So I'm going in. So let's look at that. The first question I have there is the nuclear number of atom is the total number of, remember, let's leave this. Let's check something that is much more closer to what we have learned. Now, Bohr's theory provides evidence for. Remember what we said about Bohr's theory? What did we say? We said that the existence of energy level in the atom, then positive charge of an atom, positive charge on the proton, structure of the atom. Of course, Bohr's model stated about structure of atom, but his major aim was existence of energy level in an atom. That is my answer for option A. So the next one, we said 2 isotopes of uranium are designed to be this and represent their atomic mass, atomic number, proton number, nucleon number. When you talk about nucleon number, you're talking about the proton and neutron. Okay, the last one, we have another one. It said an atom is normally electrically neutral because, okay, this one was, yes, I think many of these scientists that talked about atomic model, they believe that this is true. Atoms are electrically neutral. The electrons of atom are buried deeply in the nucleus. No. The number of electrons is equal to the number of protons. Yes. This is the reason why we say that atoms are electrically neutral. Let's look at option C. The number of electrons is equal to the number of neutrons. No, that's not true. The number of protons is equal to the number of neutrons. No, that's not true. So the option is B. Okay, which of the following particles are termed nucleons in a neutral atom? Proton, electron, and this. Neutron and electron, protons and neutrons. Protons and neutrons. All right. So we have come to the end of this class. Thank you.